Okay, so let's do one more example problem, and then we'll be done with this part of the video. Okay, so when 50 mils of H, so we're gonna do a reaction. We're gonna take aqueous HCl and aqueous sodium hydroxide, and we're gonna make salt water. Okay, so let's see how this works. When 50 mils, all right. So again, I'm gonna just, before I really even understand the problem, I'm gonna lay out a table. Volume in mils equals 50.0 is of 1 molar. Okay, concentration is equal to in molars. Okay, is 1. And sodium hydroxide looks like that's also 50 mils, and it's 1 molar. Okay, and so I'm going to go ahead and do this real quickly. The moles, if this is mils, that's going to be 0.05 moles is equal to moles per liter times liters, right? And so this is going to be 0.050 liters, 1 molar, 1 to 1. So it's getting 0.05 moles, right? That was not so bad. 0.05 moles, 0.05 moles, right? And so when they're both at 22 degrees Celsius, T1, 22, temperature goes to 28, T2, 28.9, okay? DT, didn't really leave myself enough room here, did I? Looks like it's 7.9 degrees Celsius, okay? And so the question is, what's the approximate amount of heat produced by this reaction? Well, it's done in water, right? And we know that Q is equal to MC delta T. The mass of the water, or remember that the density of water is equal to 1 gram per mil, the density of water, right? So this is, if this is many mils, that's how many grams there are. So it looks like it's going to be 100 grams total of water. 100 grams total of water, right? Specific heat of water is 4.184 joules per gram degree centigrade, because we looked that up recently, right? There's my grams cross off. And then the change in temperature is 7.9 degrees Celsius, okay? So it looks like this is going to be 100 times 4.184. 100 times 4.184 times 7.9 degrees Celsius. And we're going to get, it looks like, 3.305 times 10 to the 3 joules, right? So we're going to report this as something as, there's 3 sig figs here, 3 sig figs here. They're all 3 sig figs. So this is going to need to be reported at 3 sig figs. So I'm going to rewrite this as, this is about, or reported as 3.31 times 10 to the 3 joules, or 3.31 kilojoules. Okay, so there's our answer. All right, so obviously if you need that a little slower, you can rewind the video and look at it again. Let's move on to a couple different kinds of calorimeters now. There's a bomb calorimeter. We talked about coffee cup calorimeters. Already did, right? The coffee cup calorimeters was up here, right? Coffee cup calorimeter. There's more expensive ones. These are calorimeters, right? Now we're going to talk about a bomb calorimeter. And a bomb calorimeter is used to measure the energy produced by reactions that yield large amounts of heat or gases, such as combustion reactions, right? So we're not going to use a bomb calorimeter in class or in lab, but this time, because it's really super expensive, and obviously you're doing large amounts of heat and gaseous products, basically like a bomb, right? So this type of calorimeter consists of a very strong steel container, which we call the bomb, that contains the reactants and is itself submerged in water. The energy produced by the reaction is trapped in the steel bomb and the surrounding water, just like a coffee cup calorimeter. And here's a picture of one. This is kind of cool. And you can see, yeah, this is a pretty sophisticated apparatus. So you've got this, there's your bomb, right? It goes down inside the water. There's water that goes, there's their water right here, right? And you've got your stuff, you put your sample in and you blow it up, right? And you measure the change in temperature. Okay, And then also there are whole body calorimeters. This is kind of cool. I don't have a picture of one, but a whole body calorimeter is enough to hold a whole human body, right? So it measures the heat that your body's letting off, and it does that. And those are used to measure metabolism, essentially. And I won't say any more about calories. Okay, I think that's all I'm going to say about this. I have finally a picture here of nutritional facts of a label, macaroni and cheese. You've seen things like this before, and you're supposed to limit these nutrients because they're stuff that you can get too much of pretty quickly, and you're supposed to get enough of these nutrients because it's hard to get enough of those, and so on. So anyway, I won't say anything more about that. There's our calories, 250 calories for this macaroni and cheese, which is a capital C, so it's really 250 kilocalories. You've seen those before. All right, so that's the extent of our conversation about calorimetry.